Hello, today I'm going to have a look at the equation of lines in Core 1. So here I've got three different lines and they've all got different equations. Hopefully you can remember how to do all of this from GCSE, but just as a quick reminder, if I have a look at the blue line, or in the blue line, the y coordinate is always the same. The y coordinate is always 2. So I can call the blue line y equals 2. The x coordinate changes, but the y coordinate's always 2. The purple line, well this time the y coordinate's changing and the x coordinate's remaining fixed. The x coordinate is remaining fixed at x equals 3. So horizontal lines we should remember is y equals, and vertical lines we should remember is x equals. It's a little bit trickier when we get to a line like the red one. And the red line, we need to start thinking about our equations of lines, and I'm sure you all remember from GCSE that the equation for line is written as y equals mx plus c. And the key thing to remember with this is that m is our gradient and c is where it intercepts the y-axis. Well, the first thing that we need to do is find out what the gradient is of our line. And the gradient means every time I go across 1, how far up or down am I going? And you can see here, when I go across 1 in the x, I'm going up 2 in the y. So my gradient is going to be 2. And it's intercepting the y-axis at -1. So I can say that the equation for red line is y equals m, well we know that our gradient was 2, so we're going to say 2x, and then plus c, well because our y-intercept was -1, my plus c is going to be plus -1, so I'm just going to write that as -1. So we know the form of the equation for line y equals mx plus c, but there are actually 3 forms for the equation for line, and in Core 1 we're going to need all 3 of them. So let's have a look at y equals mx plus c first. Why is y equals mx plus c so useful? Well, if I want to draw a line on the page, then y equals mx plus c gives me all the information that I need to draw the line. It tells me the y-intercept and it tells me the gradient. In practice in Core 1, you're not actually going to be drawing lines accurately. So why do we need y equals mx plus c? Well, the crucial thing is, it is one of the easiest ways of getting the gradient. If I have the equation of a line and I put it into the form y equals mx plus c, I know that the number I'm multiplying x by is the gradient. In Core 1, there's actually 3 sorts of gradient questions you could be asked. The first one is, as we've just been saying, rearranging the equation of a line, but you're not going to get an equation in the form y equals mx plus c and be asked what the gradient is. They're going to make it a little bit trickier for you, so you're going to get a line something like this, and they're going to ask you what the gradient of that line is. The second way you could be asked about gradients in Core 1 is if you've got 2 coordinates, you could be asked something about the gradient between them. So you need to be thinking about the equations of lines. You need to be thinking, have I got 2 coordinates? Am I looking for the gradient of the line section between them? And the third way, and you won't meet this until towards the end of Core 1, is by differentiating what we call a polynomial. And a polynomial is any graph which is like a quadratic or a cubic. It's something like that. And specifically, it is not a straight line. A straight line is a specific sort of polynomial, but if it's a straight line, we're going to use our method 1, rearranging it into form y equals mx plus c. If it's something which isn't a straight line, so a curvy line, we're going to have to use something else called differentiation. You'll meet that later, don't panic about it, but just remember, if it says gradient, there are 3 things that you need to check. Is it a line that you can rearrange into the form y equals mx plus c? Do you have 2 coordinates that you can find the gradient of the line segment between? Or is it a curvy graph and are you going to have to use calculus? So let's have a look at this first question. find the gradient of a line which has equation 3x minus 5y minus 20 equals 0. So it's really hard to see that this is even the equation of a line, how it is. What we want is to get it into the form y equals mx plus c. So let's start off with our 3x minus 5y minus 20 equals 0. Now, I'm going to get my y on one side and everything else onto the other side. So I'm going to take the 5y across, and I'm going to have 5y on its own. I'm going to leave the 3x and the minus 20 on the side it's on. And now, because we need it in the form y equals mx plus c, not 5y equals mx plus c, I'm going to divide through by 5. So we're going to get y equals, now 3 divided by 5 is 3/5. And 20 divided by 5 is 4. So I can now see it is a straight line. It's in the form y equals mx plus c. The gradient is 3/5, and the y-intercept is minus 4. We're asked for the gradient, so I can just say that the gradient is 3/5. So that's why the form y equals mx plus c is so powerful. You can see what the gradient is. It's going to be the most common use for form y equals mx plus c to find the gradient. So to find the equation of any line, I need 2 bits of information: the gradient and the coordinates of the line. In the form y equals mx plus c, we're using the gradient, which is our m, and we're using the coordinate, and the coordinate we're using is the y-intercept. And we know for the y-intercept, our x-coordinate is equal to 0, and our y-coordinate is equal to c. So I've got one coordinate, but for the form y equals mx plus c, it's got to be a really specific coordinate. Let's have a look at what happens if I don't have those 2 pieces of information. So here I've got a line, but for this line, the gradient's fixed. I know what the gradient is, but I can move the point around, and that's going to move the line. So if I don't fix a point, I don't know which line it is. It could be lots and lots of different lines if all I know is the gradient. Likewise, if I know a point, so I'm going to say I know A is at 4, 3. That's not going to move. But if I don't know the gradient, my line can move all over the place. So I need these 2 really specific bits of information. And often the hardest bit of coordinate geometry is working out these 2 bits of information: the gradient of the line and the coordinate that you can use for the equation of the line. So what we'd really like is an equation of a line which isn't so specific that it needs the y-intercept. So what I'd really like is an equation of a line where I can use a coordinate which is more general. So say I had the coordinate, I'm going to be really unimaginative here. If I had the coordinate where the x-coordinate was x1 and the y-coordinate was y1. And I also knew that the gradient was m. What I'd really like is to be able to find the equation of a line just using these 2 bits of information. Now I can use the equation y equals mx plus c, because I know that at the point x1, so if instead of x I had x1, my x-coordinate, I know that my y value is y1, so I can put that in, and my gradient stayed the same, and I need to find this plus c. So I could rearrange that, and I could say, well, I need to find my plus c. C is equal to y1 minus m lots of x1. So I've just subtracted mx1 from both sides. And then once I've got my c, I could put that back into the form y equals mx plus c. But that's an awful lot of work. What I can do is I can take this general version of my c point and put it back into my equation for y equals mx plus c. So if I start off with my y equals mx, but instead of plus c, I'm going to write plus this bit, which is y1 minus m x1. Well, I've got my y1 over here, but I'd quite like all my y's on one side. Now this is getting a little bit complicated. You need to remember that the y1 and the x1 are the coordinates I know. The y and the x, which are on their own, are general points on the line. I don't know what my y and x are, I want them at the end. Just like in our equation y equals mx plus c, I had a y and an x, and I can use those to find other coordinates. So I'd like my y1 on the same side as my y. I'm going to do y minus y1. And once I've done that, I'm left with m lots of x minus m lots of, and then the specific x coordinate I know. And then to finish it off, I can spot that I've got an m in both parts here, which means I can factorise it out and make it look a little bit nicer. So I can get y minus my y coordinate is equal to m x minus my x coordinate once I've factorised out my m. This is the second version of an equation of a line. Throughout the rest of A-level maths, this will normally be your go-to equation. That's because so often you will be asked for the tangent to a graph. What I mean by that is if I've got a bit of a graph, I'll be asked for the line which just touches the graph and has the same gradient at that point. So what we'd normally do is we'd be given the point, we'd be asked to find the gradient of it. So I've then got the point, I've got the gradient, and now once I've got those two bits of information, this form of the equation of a line is perfect to use. So let's have a go at a quick example. Okay, so let's have a go at finding the equation of this red line using the equation of the line we've just found. So I'm going to take a point on the line. I'm going to take this green point, which has coordinates 2, 3. The x coordinates 2, the y coordinates 3. I could take 0 minus 1, but I already know that that's the y-intercept. If I had the y-intercept, I would just use the form y equals mx plus c. But the beauty of this equation of the line is I don't need the y-intercept. So let's have a go at finding the equation of this line. Well, I'm going to start off with my y. Just like in the equation y equals mx plus c, I've got a y which is on its own. This is the same y. But I'm going to take away, now, I'm taking away y1. And this y1 is a specific y value. It's a y value that I know. The y value that I know is 3, so I'm going to use that. Is equal to, well, m, just like in the form y equals mx plus c, m is my gradient, and I know that my gradient is 2, so I'm going to put a 2 in. Then I've got x. Well, this x is just like the x in my equation y equals mx plus c. It's just an x on its own, so I'm going to leave that x as it is, and then I'm going to take away a specific x value. So this x1 means a specific x value. I'm going to use 2 for my coordinate, and now I've got the equation of the line. If the exam question only asked me for the equation of the line, that would do. I would be sorted. But what you'll tend to find is the exam questions are a little bit sneaky, and they'll ask you to give it in a specific form. And it's not normally the easiest form to get us in. So this was a nice easy form to get us in. It might be that the exam question asks for it in the form y equals mx plus c, in which case all I need to do is expand my brackets, and then I need to get this minus 3 here to not be there because we need y equals, not y minus 3 equals. So I'm going to add 3 to both sides. My 2x doesn't change, but my minus 4 plus 3 becomes minus 1. And that gets me my y equals 2x minus 1, which is what we said it was back here at the start. Now, the observant people among you will have noticed that right at the start I said there were 3 equations of a line. We've done y equals mx plus c, and we've also now done y minus y1 equals mx minus x1. That's 2 equations of a line. Why do we need a third one? Well, if I try and write all these equations of lines in the form y equals mx plus c, or y minus y1 equals mx minus x1, we'll find it doesn't work. I can do the blue line. The blue line, well, we said that was y equals, now it's horizontal, so the gradient's 0. I can say that this is y equals 0x plus 2. Or, writing it in the other form, I could take a specific point on my line. So I'm going to take the point 2, 2, and I'm going to say y minus 2 equals 0, x minus 2. So I can write the blue line in this form. Either form's fine. We've seen that I can write the red line in either form, but the problem is this purple line. And this purple line is of the form x equals 3, but it has an infinite gradient. It's vertical. And that's a problem when I need to write a gradient in as m. So we get a last equation of a line, which is ax plus by plus c is equal to 0. And what this lets me do is it lets me write any equation of a line, no matter what the gradient is. So in this case, I could say, if a I could say was 1, so I could say 1x plus no y. Let's put in the 1 to make it nice and clear. 1x plus no y minus 3 equals 0. So this is the equation of this pink line. What you'll tend to find in the exam is, because they like nice neat answers, is they will want a, b and c to all be integers. And by integers we mean whole numbers. So not fractions, not decimals, just nice whole numbers. It's actually a rubbish equation for a line because I don't know what the gradient is. I can't get any information out of it until I put it into another form. Right, let's have a go at an exam question and see how we get on. So here's an exam question. Find the gradient of the line L, which has equation x plus 2y equals 4. So again, we'll ask for the gradient of something. We're in core 1. I'm going to think there are 3 things it could be. It could be asking me to rearrange the equation of the line into the form y equals mx plus c. It could be finding the gradient from 2 coordinates, or it could be, if I've got a curvy line, differentiating to find the gradient. Well, we don't have a curvy line, we've got a straight line. It tells us it's a straight line. We don't have 2 coordinates, so it must be the rearranging it into the form y equals mx plus c. So let's have a go at that. 7 part I, x plus 2y equals 4. I'm going to rearrange it into form y equals mx plus c. So I'm going to say 2y equals 4, take away x. So y equals, and now I'm going to divide everything through by 2. Now I'm going to put the minus x first. I don't normally like having minuses at the start, but it makes it nice and clear if we put it into the form y equals mx plus c. So I'm going to have minus x, but when I divide that by 2, I get minus a half x. And then my plus 4 divided by 2 becomes plus 2. So I can see I've got it in the form y equals mx plus c, but I've not finished the question. The question asks for the gradient. So the gradient, I can say nice and quickly, is equal to minus a half. The next question says find the equation of the line parallel to L. So this L here takes us a little while to get used to this style of questions in A levels, but this L here is the same as this L here. It's just following on using the same information. So find the equation of the line parallel to L, which passes through the point 6, 5, giving your answer in the form ax plus by plus c equals 0, where a, b and c are all integers. So again, we've got to get used to this terminology. Integers means whole numbers. That's nothing to be scared of. Just means at the end we need our a, our b and our c to all be whole numbers. We've got to find the equation of a line. That's what it's asking us for, to find the equation of a line. We know that to find the equation of a line, I need two things. I need the gradient and I need a coordinate. Well, I've got a coordinate. They've told me that 6, 5 is on my line, but they've not told me the gradient. So I need to have a look through the question and look for clues. I'm looking for words to do with gradients. And the word that jumps out to me is parallel. So parallel means I've got the line L, I've got the coordinate 6, 5, and the line we're looking for, which goes through the point 6, 5, has the same gradient as L. And we know from part I, L had the gradient -1/2. So I know that the gradient of this line must be -1/2. So let's have a go at part II. We're looking for a line with gradient equal to -1/2, and it's got to go through the coordinate 6, 5. So I'm going to start off with the equation for a line where I know the coordinate and I know the gradient. And we know that that is y minus y1 is equal to mx minus x1. I can substitute in my values. Y minus y1, well, y1 is my y value in my coordinate, so that's 5, is equal to m, well, that's my gradient, so that's -1/2, x minus x1, well, that's my x coordinate, so that's going to be 6. Now, here's a trick that's worth remembering. Before I said to change the form of this, expand the brackets, I could do that, but that's going to give me lots of fractions all the way through. And if you remember, we want our answer to be in integers, so I want whole numbers. So rather than expanding out my bracket, what I'm going to do is I'm going to multiply everything in my equation by 2. And that will get rid of my half. So when I do that, I'm going to get 2 times y is 2y minus 10 is equal to, and now I've times through by 2, so I get minus x minus 6. Now I've got rid of my fractions. I'm going to get it all in whole numbers. So I can now expand my brackets. So on the left-hand side it stays the same, but now I'm going to get -1 times x is minus x, and -1 times -6 becomes +6. Remember, anywhere you've got minuses, you've got to be really careful. And now I just need to rearrange it into the form it wanted. It wanted everything on one side and just 0 on the other side. So I'm going to take my -x and my +6 over to the other side, which will give me +x plus 2y minus 10 minus 6 becomes -16. And all that's left on the right-hand side is 0. So you can see we were asked for it in the form ax plus by plus c is equal to 0. And I've done that. Here a is equal to 1, b is equal to 2, and c is equal to -16. Actually, I could times the whole equation through by 2, and I'd still have them all being whole numbers. So there's all sorts of different answers, but to make it easy for the examiners, because they do have a hard life, give it to them in the simplest form that you can, which is like this. Right, I'm just going to do a quick bonus feature, which is having a look at some key points with graphs, just to finish off. Things that you should know, it doesn't really fit in anywhere, but sort of like a bonus feature at the end of the DVD. If I wanted to know what the y-intercept is, so I'm going to take my equation for my red line, and I'm going to take the one which we worked out the second time. I'm going to take the y minus 3 equals 2x minus 2 form. So to find the y-intercept, this point here, what I need to know is an x-coordinate to find my y-coordinate. The x-coordinate at the y-intercept is going to be 0. So I substitute x equals 0 into this equation. I get y minus 3 equals 2. Well, x is 0 minus 2. So this is just y minus 3 equals 2 times minus 2 is minus 4. And so I know that y is going to be equal to minus 1. If I wanted to find the x-intercept, well, the x-intercept here, where the line crosses the x-axis, is which coordinate do I know? Well, I know that y is equal to 0. So it's a little bit counterintuitive, but it makes sense when you look at it with a picture. Unfortunately, in the exam, you're not going to have a picture. It's worth drawing a sketch if you're not sure. So we know that y is equal to 0. I can start with my equation for my line, and then just put 0 in for y. So I'll get 0 minus 3 equals 2, x minus 2. So I get minus 3 equals 2x minus 4 by expanding my brackets. I add 4 to both sides, which gives me 1 equals 2x. So my x-intercept is going to be at a half. Let's just check that that was correct. You can see here my x-intercept is indeed at a half.